In this video we'll discuss circle foundations. Now a circle is a collection of all the points on the plane that are a fixed distance away from a given point, and that will represent the center of the circle, and that's also how we'll name it, is by the center. We have radii and the diameter, where the radius is the distance from the center to any point on the circle. The diameter is going to be the chord that passes from one side of the circle to the other and has to go through the center. So it's a very special chord inside of our circle. And what we know because of that is that the diameter is twice the length of the radius. So if we look at this circle down here, we would name it by the center, so we would call it circle J. If we look at the radii, it's every segment coming from the center to the edge. So we've got segment JK, segment JM, and segment JL. All are radii, and they are all the same length because of that fixed distance. We also have one diameter in this image, which is from segment KL. Now within circles, we also have other ways that lines and segments intersect, and it's important to know what those words mean. For example, we have tangents. Tangents are lines, or could be a segment, that intersects a circle at exactly one point, whereas a chord is a segment that is inside the circle whose endpoints are on the circle. Does not have to go through the center, but the endpoints have to be on the circle. And the last one here is the secant. And the secant is a line that goes through the circle and hits it at 2 points. Therefore, it contains a chord of the circle. Now we also deal with different types of angles in circles. Two primary types of angles we discussed are the central angle and an inscribed angle. Whereas a central angle is formed by two radii, so if we look at our circle A here, we would say that radius BA and radius AC are forming angle BAC. When we talk then about the inscribed angle, it's formed by two chords. So if I created a point D on the circle and then connected B to D and D to C, I would have inscribed angle BDC. And what's important about this is if they open to the same arc or the same circumference portion of the circle, then we know that the inscribed angle will be half the measure of the central angle. So if I knew that angle BAC, say this angle, my central angle is 50 degrees, I would know that my inscribed angle would be 25 degrees. Now an arc is a section of the circumference of the circle. And when we talk about arcs, we talk about arc length and arc measure. If we're talking about the arc measure, it's the measure of the arc between the central angles. So if we look at our image down here, we have our central angle. We're talking about what would be in between it, since this is our marked one, IKJ. Now minor arcs have to be less than 180 degrees, and we'll use two letters to describe them, whereas major arcs can be used for any marked measure but must be used for measures over 180 degrees, and they require three letters for that reason, because the three letters tell us how to go about naming that arc in the specific order. So here I have the measure of arc IJ. That means I'm going to go from I to J in the shortest distance possible, and that's going to be the measure that matches with the opening of that central angle, which would be 110 degrees. Now if I said the measure of ILJ, that means I'm going to go from I through L to J. And so the angle, central angle I'm looking at, it looks kind of funny, but it's the opposite angle of the 110 degrees. Hence why we could do 360 minus 110 to get that this would be a 250 degree arc measure. Now other arc relationships include the fact that we have the arc length, whereas the arc measure is a degree measure of the 360 degrees of a circle. The arc length is the portion of the circumference that falls on that arc. So to do that, we're going to find the circumference and then figure out the fraction portion of that circumference that we have. Hence why we say that the circumference of that's why we use C for C of A, means circumference of the arc, or the arc length. It's going to equal that arc measure, which is the same as the central angle, over 360 times the diameter times pi. And diameter times pi, that's just the circumference of a circle. So say we have this circle here, circle F, and we want to find the arc length of arc GE. Well, what we recognize is we can figure out the circumference because we have the radius, and the radius can be doubled to give us the diameter. And we know that the arc measure is the same as our central angle. So if we put in our pieces, our arc measure over 360 times 18, again, because that's twice the radius, times pi. So here's our circumference, and here's the fraction of the circle we're looking at. 1/6 of 18 would give us 3. So the circumference, or the arc length, for arc GE is 3 pi. Now we also have this notion that if we have a chord that is perpendicular to a radius, the radius is going to bisect that chord, but it's also going to bisect the arc, which can be very useful depending on what we may need to know about the image. So in this case, you can see that what we would know is that if SU had a length of 6, each SP and PU would both be 3, and if we knew that the measure of arc SU was 64 degrees, we would know that the measure of arc ST and the measure of arc TU would both be 32 degrees. Now there's other relationships that can exist as well, including relationships that occur with the tangents in a circle. First, we know that if a line is tangent to the circle, then it is also perpendicular to a radius at the point of tangency. Well, what does that mean? So let's look at an image. If I look at this circle, on circle A, I have line DC, which is perpendicular to segment BA, which is a radius. So we would say that we know that that is the point of tangency there at point B. And why would that be useful? Well, if you think about having that right angle, if we connect D to A and create that segment, we have a right triangle, which could be useful in trying to find different segment lengths within a specific image. Also, we know that if two tangents to a circle have a common endpoint, then those segments have to be congruent. So again, here we have segment FG and segment GH, which are both tangent to circle E, and so they're going to be perpendicular to FE, and EH is going to be perpendicular to HG. That also tells us then that FG and HG are going to have equal measures. And we could go through here and find a lot of different information, again, around the idea of right triangles. Because if we just drew in a segment from G to E, we would end up creating two congruent right triangles, and we could base that off of the idea of side, 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 or even side angle, side congruence.